This is Dr. Isla, and I'm here to talk about X-rays and the films and screens used to make an image. This is an X-ray film. A permanent image is recorded on it after being exposed to photons, which we'll explain later. There is a base layer that is tinted blue or blue-gray, and it is coated on one or both sides by emulsion. Emulsion is the active layer on the film and contain crystals of mostly silver bromide. During development, the crystals that were exposed to light turn black after processing, and the remaining silver is washed away. Now, single emulsion gives better detail, yet double emulsion allows for a lower patient dose, and you always want to do as little as possible in terms of exposing your patient to radiation. The double exposure means that there are more receptors, which allow you to lessen the dose and still capture the image. Double emulsion also means that you will have parallax, because the two images are superimposed on each other. The resulting blurred edges are why single emulsion gives better detail. There are different types of films, but since screen film is what is most commonly used in diagnostic imaging, it is what we'll be focusing on today. The varying size crystals you see in the emulsion layer allows for more shades of gray. This is called contrast. Another aspect of using film is the speed. Double emulsion is faster, a thicker emulsion is faster, and a larger size crystals are faster. All this helps reduce patient exposure. This specific film is orthochromatic, meaning we must use a red filter light while handling and developing. This particular film was stored in a cool, dry, dark storage bin to minimize film fog and other artifacts. This is a cassette. It is used to protect film from being exposed to light, as well as from bending or scratching. It also contains an intensifying screen, and the film is kept in close contact with the screen during the process. The X-rays can easily penetrate the front of the cassette, which allows the X-rays to interplay with the phosphors in the screen. This interaction causes the phosphors to glow, which is what the film is exposed to. Because film is more sensitive to light than to X-rays, you can use a lower radiation dose and let the phosphors do the work of exposing the film to the image. So from front to back, you have the cassette, which has a plastic front to allow penetration, and a pressure pad to keep the screen and film in close contact. Then the screen in the cassette has a base layer, a reflective layer, an active phosphor layer containing the rare earth phosphors. Then the film in contact with the screen has an overcoat, an emulsive active layer, an adhesive, and a blue tinted base. And lastly, the back of the cassette is lead backed to prevent backscatter. Issues with any aspect of what was discussed will lead to image artifacts, crossover, and/or image noise. Screens should be cleaned once each month with a manufacturer's cleaner with anti-static compounds to help ensure a clean image. Now let's put it to practice. I'm in my dark room with my red filter on. I insert my film into the cassette and secure the back to make sure no light can get in. I place my cassette in the grid, which also helps further reduce scatter to improve image contrast. I give my patient clear instructions like stand perfectly still and determine my MAS, KVP, and use my beam restricting device based off his proportions to give as little dose as possible while still getting a usable image on the first try. I take my X-ray. I then turn on my red light filter, remove the film from the cassette, and put it through the developer. And after, I will then get my manifest image to use for diagnostic purposes. Now that I have my X-ray, I can proceed with chiropractic treatment.
Thank you, Dr. Isla.